Charlton, people asked you to watch the video. Why you didn't watch? Okay, please actually be more consistent. Yeah. Okay, those videos that I share you normally, I share that. Okay, for a reason, because sometimes I want you guys to know about the content before I do the worksheet. Yeah, there is some content over there in the video.
That's the yesterday discussion on, yeah?
Again?
The video, the yesterday's discussion, right?
The video, not the yesterday's discussions one. The video I sent in the WhatsApp group yesterday after school. It's called rate determining step. Or you can just go and search under YouTube, BBSPIKCHEMISTry rate determining step.
Oh, which video is it?
Rate determining step.
Oh, that I haven't watched.
Yeah. So that one is very important. Yeah. That is the part that there are two questions here in this particular worksheet that I have discussed using that video.
So we watch now.
Actually, no need. You can actually watch it later after lesson. Yeah. So if you see the question on rate determining step, yeah, that is actually I have already discussed in that video. So you just do the thing like normal. But anyway, I'll see whether I can allow you to share the screen. Justin, you can share your screen if you want, yeah. So you have discussion there.
Two and three.
Two and three. Yes, and
Hi,
three.
sir.
I have enabled screen sharing. So if you want to share your screen, you can do like yesterday.
Okay. I haven't downloaded, sir. Very long. My Wi-Fi is so slow.
Or someone who downloaded can actually share. So anyone can share here. I already enabled that. Or you want me to send through WhatsApp? But again, you need to transfer it.
Yeah.
Yes, sir. Can you send it through WhatsApp?
Yeah, I can send it through WhatsApp. Hold on, yeah. Okay, I sent that. Still sending. Yeah. Sent. I'll just straight away use examples. Okay, I have actually two examples over here where I can actually show you about this rate. Okay, about rate. So here, rate determining step. Yeah. So here, like for example, you see here this compound. Okay, is going to be first order. Okay, the rate is first order with respect to NO and F2. Okay, it means that if I have rate equation, I will write down rate equals to K and then NO and F2. And then the M and N, the power is going to be 1 and 1 because they already mentioned it's going to be first order. Now, if you look at the equation over there are only two reactors over there, and both of the reactors are inside the rate equation. It means if you want to actually suggest a mechanism of this reaction, they say that the reaction has two steps, and they ask us to suggest equations for this two-step mechanism. And we need to tell which one is the rate determining step. Now, do remember rate determining step, okay, is going to be if let's say you have multiple steps, step number 1, okay, step number 2, maybe you can have step number 3. So the first step is going to be your slowest step. Okay, the first step is going to be the slowest step. And that slow step, the rest are all fast step. Okay, the slow step is going to be the one that is actually going to give you the if you have the rate equation and they are there, it means that all the reactants that we put in the rate equation must actually exist in step number 1, okay, which is going to be a slower step. Okay, so the other reactors, okay, that are not reflected in the rate equation, they will come under the fast step. Okay, so there will be some intermediates will be formed, so we need to actually eliminate them. So if you look at this example over here, we know that your NO and F2 must be in the first step. So let's say, for example, step number 1, okay, step number 2. Okay, your first step must have, okay, NO and must have F2. So I need to come up with a way, or think for a way, how can I actually come up with something, an intermediate, okay, so that that intermediate can be cancelled in step number 2. So I can actually have 2 steps. So what I can think now is probably maybe if I put NOF2, for example, okay, when they form NOF2. So you notice that NOF2 is not in the product, okay, in this equation. So probably that is the one that I created, okay, the intermediate. Okay, so in this case, what I'm going to do is, okay, I need to eliminate this NOF2. Yeah, I need to eliminate. I need to figure a way how to eliminate that. Okay, so when I write NO here, when I see there's 2 NO, probably if I can actually add another NO here and come up with something. Okay, for example, I need to have 2 NOF. So if you see here 2N, okay, 2 NOF is balanced. Okay, if I add step number 1 and step number 2, okay, the NOF2 and NOF2 will be cancelled. So I'm going to actually get the same equation over here. But the important thing that I need to notice is this one, both of this, they are in the slow step. And this is going to be the fast step. And this is going to be your rate determining step. Okay, rate determining step. So is there other ways to actually write or do this? Yes, there's another way. Okay, another alternative for it. Okay, so let's say I write it over here. So what is going to be the another alternative? Okay, so if you have 2 steps, step 1, step number 2. Okay, and I know that the NO and F2 must be there, okay, because they are in the rate determining step, yeah, because they are inside the rate equation. So probably instead of NO F2, can I think about something else? Probably I can think about NOF, okay, plus F, okay, if I have something like this. And what I have created over here is this F. Okay, I need to actually remove this F. Yeah. So how do I remove this F? Okay, so I need to remove this F. I need to figure out a way. So NO, so there's 2 NO, so probably I'll just put 1 NO here. And I need another NOF, so probably I'll just put something like this. So whereby when I add step 1 and step 2, okay, the F will be cancelled. And you are going to get 2 NO plus F2 to give you 2 NOF. Okay, so this is going to be my slow step. Okay, and this is going to be my fast step. And this is going to be obviously your rate determining step. Okay, do remember, you must make sure the number in front here, okay, tallies with the order. Okay, for example, it's actually for the first order. It means that now this one must be 1 and 1 because why they have mentioned is going to be first order. So it means the number that we have over here cannot be, let's say you cannot add 2 F2. Okay, because it's just, we need to follow that number. If it is first order, then the number must be 1. Okay, you can see over here, this is first order. You can see this is number 1. This is number 1. Okay, one more. We are dealing with 1 more. Okay, so if let's say you want to actually do another example. Okay, if we do another example, you can see here. Okay, this is another example. The reaction between X and Y was studied. Okay, and then this is the equation. And then they say that there are 2 steps proposed for this reaction. Okay, first step, step number 1, and step number 2. Okay, and you can see the first step do not involve Y. Yeah, the Y just came in the step number 2. The general form of the rate equation is going to be given here. And then they mentioned that step 1 is the slower step. So this is slow step, which is your rate determining step. Now, if this is rate determining step, it means that I know that there is no Y. Okay, the reactant, Y is not in the rate determining step. It means that Y should not be even inside the rate equation. So how do I get rid of that? Simple, by putting the rate equals to K, okay, X, M, I do not know. Y, I don't want it to be there. Just put 0 because anything to the power of 0 is going to be 1. So it's kind of Y, you are removing the Y. Okay, so the N, we already know the N is going to be 0. And then for M, okay, do remember, as I mentioned to you just now, if this is 1, this is 1, okay, it means that this is going to be 1 and 1. Okay, if this one is 1, this one is 1, that is going to be 1 and 1. Do remember that. So here, okay, if you put this is going to be N, you can see that for the rate determining step, this is going to be 2. Okay, it means automatically your M will become 2. So this is going to be a second order reaction with respect to X.
Sir, what if it's two? What if, example, there is 2 reactants and one is 2 and one is 3. So the
Can you annotate? Cannot understand.
write it down. I cannot
Yeah.
write down.
Write it down.
Okay. Example, if the reactant one is 2, the coefficient, and then other one is 1. The order of reaction is which one?
It means, are you talking about the slow step?
Yeah, this is that.
Okay, let me share the screen here. Cannot share the screen. Let me actually bring my iPad here. Wait, yeah. I'll come back again.
Sir, I think you're muted.
Okay, I'm muted. So anyway, so basically you have, let's say for example, you have this equation A plus B to give you C plus D. And then they mentioned the rate equation is K equals to this, okay, second order towards A, first order towards B, for example. So they said come up with a suggested let's say there are 2-step reaction. They mentioned this is going to be 2-step reaction. And then we need to come up with a way to make sure, like for example, since there's A, there is B in the rate equation, my first step, which is going to be my slowest step, must have A, must have B. That is for certain. But another thing that you need to take note is, okay, you must make sure that these two, right? If you have 1 here, it means this is 1. Okay, this is 1. If you have 2 over here, this means 2. You have to really understand this part. Okay, so this one, when you add, okay, let's say 2A add with B, let's say according to this equation, I try to match. Okay, maybe I want only 1A, so maybe I get another 1A. Okay, maybe A, let's say AC, okay, plus D. I'm just coming up with something random, yeah. So after that, okay, I need to how to say, I want to actually make it back to A. So maybe AC, I want to destroy AC because that is something that I created, yeah. So I need to put it here. So when I add this 2, then the C will get destroyed. AC will get destroyed. So I need to form C, of course. Okay, I need to form C. And then I need to figure a way how to make the A, this one of the A that I added earlier to disappear. So maybe I put A. Okay, I put A. Then that's all. Okay, I think that's all. So when you add up, okay, when you add up, what's going to happen is the AC will cancel. So I have 2A plus B to give me C plus D plus A. This A, bring it over here, it's cancel. You'll get A plus B to give you C plus D. You are getting the same thing. So it means that when I came up with the method, this is going to be a slow step. This is going to be a fast step. I came up with a 2 steps reaction. But the important thing that you need to notice over here is this must be 1B, this must be 2A because of this. Can you understand? Because that value, okay, in the slow step, okay, remember last time I told you whatever that you get from here, you cannot use the number that you have in front here for the rate equation, okay, because they are not rate determining step. Okay, they are not the rate determining step. But now, okay, my connection is not stable. Maybe it's not so clear. But again, do remember, okay, when you write down, okay, your slower step must have the, like, it will follow your stoichiometric equation, the slower step. So the slower step must have that 1. So 1. This one, because 2, must have 2. So that is actually what I told towards the last part of the example in that paper. Ken, Lavi, I think, does it answer your question?
The order rate of reaction, sir. Is it 2 or 1?
The order of the reaction here is actually the order in respect to A is 2. The screen froze. Okay, but again, you see, the order of the reaction, we always refer to the rate equation. The order of the reaction is, this is a second order with respect to A, second order with respect to A, first order with respect to B. If they ask you what is the overall order is 3, 1 plus 2. So it is impossible, Lavi, to actually draw a graph which has the concentration of both A and B. We don't do that. We only draw a graph of this either for A or a graph for the concentration for B. So if, let's say, I want to draw a graph for rate against concentration of each one of them, because for A is going to be second order reaction, then the graph will be like this. And for B, if it is going to be first order reaction, then the graph will be like this. I hope you understand. So there is 2 different graphs. So we don't see them like overall 3. How do I draw? No, actually we see them separately. That's why they use the term with respect to. Okay, so order of reaction with respect to A is 2. With respect to B is 1. So we can actually determine the order by looking at the rate determining step. So if this is the rate determining step, the moment you see 2 there, then it's second order with respect to A. If you see 1 over there in the rate determining step, then it's actually first order with respect to B. But normally we don't get the rate determining step because that one is actually what we propose. It's not actually, we cannot actually really see that reaction. This is a proposal mechanism. Like, for example, you know, when we do equation or mechanism about nucleophilic substitution, that is actually a proposed mechanism. It's not the actual mechanism. I hope you understand. So those proposed mechanism, we come based on the rate. All this way that we do, then they actually determine that it might happen this way. Then they actually use this. They cannot simply say it might happen like this only. They have to use the, you know, the rate. Okay, if its rate is changing like this, then they propose the mechanism. So they don't simply come up with a mechanism also. Does it answer your question, Lavi?
Sir, thank you.
Okay. Please complete
Okay.
the worksheet, the 2 questions. There are 2 questions and you can see the questions are long questions. Okay. So it's taken one from 2014, another one is 2017. Okay. So the gap is 3 years. So every 3 years, there will be one long question for rate equation. If you're lucky, maybe you get, but this is easy question actually.
Sir, I have a question.
Yeah.
If, for example, the equation is A plus B plus C, but the working is only showing the rate of reaction for A and B, but doesn't involve the C, so does it mean the equation is a fast step and not a slow step?
Yes. Like, for example, okay, if let's say this one, instead of I change this. This one's supposed to be plus C to give you D, for example. And then inside the rate equation, C is not there. Okay, C is not there. It means that, okay, the C is not going to be in your slow step. It will not appear in your slow step at all. Okay, but it will appear in the fast step. Okay, maybe this one we can delete. Something like that, yeah.
Yeah. And like yesterday's example, there is the plus H ion, right?
Yeah,
So that one is the second step.
yes, it will come under fast step.
But how do we know if the question doesn't state if whether it's a slow or fast step?
The question will not state it's slow step or fast step, but we refer to the rate equation. So if let's say the H plus is inside the rate equation, it means that H plus is inside your slow step. Like for example, yesterday's question, okay, like I'll show you the yesterday's question. I think I need to start to put everything into folders. Too many things. Okay. Anyway, this is yesterday's one. Okay. Can you see here? They anyway write the rate equation. Now, this one in this particular question, okay, what I have here, I found that, okay, that ACL, okay, using the experimental data, I found out that ACL has first order. Okay, so that is a way to actually identify, yeah, experimental data. So when I have that, I know that the rate equals to this. Okay, it means this is my rate equation. Yeah, the H plus is there. So if let's say they ask you to actually come up with a mechanism for this reaction, so the mechanism of this reaction must be your slow step must have H plus propanol to give you something. And then the the fast step, because the H plus is a catalyst, it means the fast step must actually have product as H plus so that you can cancel the H plus. I hope you understand this. So you get to know based on the experimental data sometimes, or sometimes they look at we look at the rate. So in this case, they didn't ask you to come up with a slow step mechanism, okay? But that is how you actually identify by using experimental data. Okay, once you have experimental data, then you have this. It means this is an indication that your slow step definitely involves H plus and propanol.
Okay. How about the case for the previous number, where the H plus is not involved?
Or I think let's actually look at this example where I2 is not involved. I think it's the same question also. Yeah. So you see the I2 is the reactant, right? Okay. So I2 is not involved in your rate determining step because it's zero order. It doesn't actually, the concentration doesn't affect the rate equation. Yeah? So when it's zero order, so the I2 will be here, somewhere here under the fast step. So they will be still here under fast step, but it cannot come under the slow step.
Sir, the I2, how to know if it's zero order or what?
You can actually, for zero, to identify zero order, there's two ways, which is going to be one is by using experimental data. Second is by using the graph. Okay, that is how you identify. So here I found out this one is zero order because I know when this one become double, nothing changed here. So I know it's zero order. Can change. So in this particular case, I use experimental data. Sometimes you can actually use your graph. If you have graph, you can actually identify that they are zero order. Okay. Anyway,
so if like divide by 2, 0, yeah.
Yeah. You write down 0, but again, when you write down here, because it's 0, no need to even write down because anything to the power of 0 is 1. So they will disappear. So anyway, okay, there is a time limit for the breakout room, I said. Okay, so never mind, I will actually close the room, then I'll open again. Yeah. Arnetta, sorry, I was actually discussing one question with Lavi. I cannot leave just now. Okay, I will actually I made a yesterday setting. I put the breakout room limit as 25 minutes. Yeah, so that's why I have to close. So do you want to continue your discussion? I don't think so. Yeah, because some groups they still haven't started with the thing. I was explaining about the rate determining step to Lavi's group. Okay, so I will open the breakout room again. Okay, you can join. If you have any question, like now I will actually join Aneta's group. If you have any question, you just ask me. We will do this, I think, until the end of today. Yeah. The aim is to complete this. If you have done, let me know. Okay, so that we can continue with the PowerPoint. Yeah. I'll open the room now. Yeah.
It's my fault. I wanted to ask for help. I thought I want to try to annotate, but I didn't know it was all for you. So can you enable annotation so
Oh,
we can go easily?
wait. I didn't know that I disabled that. Hold on, yeah. I think that was actually the setting is in the main. Let me see. Let me go to the main room and figure out the setting. Yeah.
Okay, thank you, sir.
Wait.
I don't know how to enable it. So maybe Aneta, can you actually share something? I think there should be whiteboard. I think there's no. Can you actually? I think if you want to annotate, you have to share and then click whiteboard, and then you should be able to annotate.
But the rest cannot annotate, sir. Only the person.
Okay, let me actually see. Yeah. Within our room now, I cannot change any setting. So that actually controlled by the main room setting. So I think the school have removed the annotate, so they don't allow you to annotate. You're muted, Aneta.
Wait, can you guys annotate now? I think I found the settings already. I think.
Can you try the others?
I still don't have the annotate settings in my here.
No pencil?
Here,
No,
I can
usually
actually
have basic annotate, but here
yes. Like for example, I share my screen. Yeah, you can see if I put whiteboard, I will have something like this. Then I put there is annotate here. Draw, then you can draw.
Hmm.
Can you try?
Oh, can you see mine?
I see someone right. Yeah,
Janice.
Yeah.
Oh, I can.
Yeah. I think you just need to go under view options, then actually press annotate. Is there? Actually, there is another way to annotate using the document. You can collaborate. That one we try some other time. Yeah, it's an external program. Okay, where you can write collaborate together. Like when you have a PDF, okay, then everyone can write on top of the PDF. That's actually cooler, way cooler as well. We'll try next time.
Already can. Okay.
Yeah.
Thank you, sir.
Yeah.
Thank you, sir.
Jas, lu punya NO apa, Jas? Second order? Second order because increase initial concentration by 3. B. Concentration and over 0.09. This way. Over 16. Good call. Rate constant rather than rate divided concentration. Rate divided by concentration. Zeta. Explain why the rate decreases with decreasing temperature. Hah?
Bisa gak?
2DV, Mas. Jas.
Atau oh, hampir selesai.
Oh. Gua nggak tahu yang itu. Yang di itu lah, yang di itu. Wah, gimana saya? Step 1 is the slower step.
Gimana, weh?
Wah. Kayaknya M-nya 2 deh. Enggak. N-nya 1, N-nya 1. N-nya 1. Enggak, N-nya berapa ya? Enggak, N-nya
Satu
0
ya?
weh. Enggak, N-nya 0 weh. Kan enggak ikut
Oh iya.
pertamanya. Rate-nya, ya kan?
Kan berapa? 1 ya?
M-nya gue nggak tahu gimana. Pokoknya N-nya 0 ya. M-nya gimana? Jod, lu di mana?
IB.
IB.
Iya, tahu.
Di 2C IB, Jod.
Enggak.
Yang mana?
Iya tuh si IB.
Orang nggak ada lu 2C IB ya, mabok deh. 2C II.
IB.
IB apa lu? Oh,
IB.
IB. Oh,
Ada
IB. Gue Jas, gimana Jas yang M?
Hampir 1.
Dapat dari?
Atau asal aja.
Seingat gue 1 sih. Gimana ya? Berarti kan V situ. Habis itu V plus Y jadi Z. Yang tuh CV lu udah bisa, Jas?
Belum.
Ayo, gimana nih? Rate equation explain why the rate decrease with decreasing temperature. Decreasing temperature.
Wichel.
Hah?
Ini didiskus sama si Gopi di videonya. Katanya 2 nih. Iya, katanya 2.
Apa deh? 2? Masa? Gara-gara?
M-nya 2. Coba lu
gara-gara apa?
Karena ini ada 2 sini.
Nggak mungkin gitu dong.
Atau ini si Jason.
Emang gitu dong?
Iya.
Ya udah.
That's why we asked you to actually watch the video. You don't want to watch. Now you're not sure.
Oh, you here, sir?
Sir. How do you number visa? How do you do
Actually,
visa?
this one, right? Which one? You're circling 4 or D?
This one, V.
D. Oh, yeah, that also kan.
By considering the, okay, let me see. By considering the rate equation, explain why the rate decreases with decreasing temperature. What is your rate equation?
The equation is
Uh,
1.
Actually, no need the equation by considering normally rate decrease with decreasing temperature. So you follow the rate equation. So what is your A and B? Can you tell me?
A and B.
A, B.
2 and 1.
2 and 1, yeah.
2 and 1, right? So it means both of them are the NO and Br2, right? So it means we just think that NO, they are reacting with Br2, right? So when temperature is decreasing, what happen is the collision between the NO and Br2 will become less frequent. So when the collision, because they don't have enough energy, so when they become less frequent, okay, the less effective collision will happen. So reaction will be lesser.
But kan Mas link with the equation.
Yeah, we link with the equation because I know if it is like, let's say, for example, B is 0, right? If let's say B is 0, it means there's only NO. Then I only explain about NO. So now if I link with the equation, there's 2. So it means you need to mention about NO and Br2. So they're colliding. Yeah.
So the D, why the M2? Sir?
Yeah, how do you
This
get
one
2,
I
sir?
already mentioned in the video. Even though, like for example, when you write the stoichiometric equation, we do not actually use the stoichiometric value to for the rate equation. But when it comes to rate determining step, okay, the rate determining step, the value in front of them will be applied as your order of the reaction. So it's a proposed mechanism. So we know if it is actually rate determining step, then it will be involved in the order of reaction.
Oh, so the okay.
If let's say, I think if I share my screen, okay, actually I cannot share my screen over here. Okay, wait there. I go out and actually bring my iPad here. Hold on.
Okay. Itu pura-pura goblok teh. High school, Jod.
I'm muted. Yeah. So now you see, let's say you have a situation where you have A plus B to give you C and D. And then using the experimental data, you found out that rate equals to K and A and B, for example. You have this, okay? So this is going to be based on the experimental data. Let's say this one is to the power of 2, okay? Second order with respect to A, first order to with respect of B. So what happens over here is when, let's say they say this one has 2-step reaction, okay, step 1 and step 2. So your step 1 automatically is the slower step. And this slower step is the rate determining step. You need to understand that. Now the rate determining step, they will follow, okay, your rate equation. It means if inside your rate equation there is A, there is B, then you must have A and B in your reactant over here. Okay, you must actually have A and B in your reactant over here. And then please take note of this number 2 and number 1 over here. If there is number 1, then it's 1 mole of B. And if you have number 2 over there, it means there's going to be 2 moles of A. Can you still hear me? I think
Can sir.
let me share the content, share my screen again, yeah. The important thing over here is, okay, you look at this 1 and then look at 2. Automatically, you need to know that 2 must come over here. B must come over here. So whatever that you want to predict, let's say the mechanism or something, you must actually use this to write the equation. So like, for example, I want A plus B to give you C and D. How do I write equation that actually will give me something that satisfies that? So probably I'll come up with 2A plus 1B. Maybe I will give you C first. Okay, I will give you C. And then later, because maybe I'll introduce something new, CD plus D. Okay, let's say I get CD plus D. I already have D. Okay, I introduce CD. Okay, I introduce CD. So I need to get rid of CD. I put it over there. Okay, so that when I add the equation, CD can be gone. Then I must actually have C. So I put C there. Okay, and then here I just need 1A. If I need 1A, I have 2A here on my left hand side. So put A over here so that the A will cancel with the 2A. And then let's see if I add this, okay, am I going to actually get the same equation that I wanted? So 2A, okay, CD will cancel, 2A plus B, give you C plus D plus A. You come over here, you'll get A plus B to give you C plus D. So it's okay. So this one will come under fast step. So this is how you come up with the mechanism. So the important thing is your slower step must have all the things inside the equation, A, B, and then if 2, then it must be 2 there. If it is 1, must be 1 there. That is very important. Now, there's another question. What happens if we have C like this? If I actually put this, let's say plus C and give you D, for example. And then C is not in the rate equation. It means C is going to be 0 order. Okay, so C is not in the equation. So how do I actually come up with a mechanism, okay, to show this equation? So here you see C is not in the rate equation. So C should not come in your slower step. You can see there is no C. There's no C. So the C must only come at the fast step. So you cancel this. Cancel this. So this is going to be another way to tell, yeah. Like for example, if I add this, I will get A plus B, okay, to give me no C. C is cancelled. Okay, this C, sorry, C is not cancelled, so there is C here. A plus B to give you A plus B to plus C give you D. So the one that A you bring over here, so you basically you get this. So the idea is, okay, if you have, let's say this is going to be the reactant, but they are not here, in what step I should put C? It will come under fast step. You cannot put the C in your slower step. Can you understand this?
Sir,
This is actually done in the video. Yeah.
if in the already in the mechanism, the coefficient is the order.
Yes, but only for the slower step. So it means if it is already here, okay, your slower step, if you have the coefficient of the stoichiometric coefficient, will be used as actually the order of the reaction. Only for the slower step. You cannot actually simply use it directly from the main equation. This is actually some suggestion, like for example, everything, like for example, nucleophilic substitution mechanism. Okay, we suggest the mechanism goes SN1 and SN2 based on this knowledge, reaction kinetics. Then they came up with the slow step and fast step and so on. Okay, basically all this, okay, it's actually derived from the rate equation, the experiment. Okay, anyway, Arneta is asking for my help. I'll go there. See you guys.
Bye, sir.
Yeah.
Bye, sir.
Yes.
Sir, can you explain the last number?
Okay. let me bring my iPad. Yeah, to you guys are room number 3, is it?
How do you know?
I also don't know.
Room 2, sir.
Room 2. Okay.
Oh yeah, room 2.
So which one?
The last one, sir. D.
This one?
Yeah.
Yeah, this one is what I explained. Oh, I didn't explain to you guys. I explained to Lavi and the other groups. Actually, this one, okay, you based on the video that I shared, okay, if you have a slow step or rate determining step, okay, the coefficient that you have in the rate determining step will become the order of the reaction. Okay, so it means that if this is x, okay, so 2, so this is going to be 2, and y is not in the rate determining step, so y should not be even here, so this is going to be 0. Okay, in a simple form, okay, I was actually explaining that before I come over here. I'll put it in this way. Like for example, if I have a plus b to give you c plus d, for example, this is the equation. And then if I have a situation that let's say the rate equation, the rate is going to be k, a to the power of 2, b to the power of 1, for example. Okay, you got it from your experimental data. Now, if they ask you, this step actually has a two-step mechanism. Okay, so we want to write it as step 1, step 2. And I know the first step is going to be the slower step, which is the rate determining step. So when I actually write down the slower step, I need to consider all this. If this A and B is inside your rate equation, it means A and B must be here in your step number 1. Second thing that you need to consider is this number 2 and 1. If there is 2, automatically must put 2a there. This one must be 1. So whatever that you want to do now must be based on this. Okay, let's say I want to come up with a situation to give you C and D. Let's say I create CD, something new, CD, and then they are giving one of the product, let's say D. Yeah, and I need to eliminate the CD. So I put the CD on my another reactant for the fast step. Okay, and then I know that I need to only react 1 mole of A. So let's say I form A. So later when I add, the A will cancel, yeah, with one of the A. And then I know that I didn't create C yet, so I create C now. Okay, when I add, I will get C. I think that's all. I think that's all. Okay, CD will become A and C. So if I just add them, I'm going to get 2A plus B plus CD to give me CD plus D plus C plus A. You can see the A, if I bring, is 2A minus A, okay, plus B. CD and CD will cancel. It gives you C and D, okay, which is the same. So this is going to be my slower step. Now, after that, Lavi asked me, sir, how if you have something like this, okay, if you have plus C, and then the arrow is actually showing to form D, okay, to form D, A plus B plus C to form D, but the inside the rate equation, you don't have C. It means C is 0 order, okay, C is 0 order. It means that whenever you write the equation, you must make sure C do not come in your slower step. That is very important. C should not be in your slower step. Okay, there's no C. So now let's say I rearrange. Okay, I put the C here. Okay, so if I put the C over there, so I know that if I add all of them here, okay, you are still going to get the same thing here. So what is going to be my slower step? My slower step is still this. So the fast step, okay, is C. C is still reactant, but they are not in the slower step because they are 0 order.
Sir. So we were concerned about the thing that you said, that we were not allowed to see the rate equation by the stoichiometric equation, sir.
We should not look at the stoichiometric equation in the main equation.
So if like slowest,
If
you
it
know,
is
like which one
already
is-
slowest, you can look. And this is proposed by us. Okay, proposed by us, or sometimes if the question proposed, this is going to be the slowest step. Like in this question, they say this is slow step. They already proposed. Okay, so automatically these two will come over here. This is 2. And this one, because they come over here, okay, y. So, and y is not even appearing in the slow step, so it must be 0. So that's the meaning. So everything, this thing is inside the video. Yeah. So anyway, it's already time. So we go to the main room. Yeah. Guys, I hope you learn something through the discussion. Okay, please go through the video. The video that I shared yesterday is very, very important. Okay, so it clears a lot of doubts. Okay, I think even some of the good students, they won't actually understand this rate mechanism. So I took the effort to actually compile the question and put it over there. Okay, so that it will be helpful with for you. I want you to also learn about the AS stuff, which is going to be Maxwell-Boltzmann's curve. Okay, you can refer to the textbook how to draw. Okay, please actually complete this. Okay, if you need answer key, I have the answer key. Okay, if you have done, let me know, then I will actually pass you maybe the one that I annotated. Okay, I can actually pass it to you also. Yeah, so that's it. It's already 12:35. You go for your lunch. Okay, before you go, any questions? Okay, no questions. See you. Bye, guys. See you.
Sir.
Bye, sir.
See you.
Bye, sir.